Welcome back to 7.5, solving quadratic equations by factoring. Let's begin. 7.5 is similar to 7.4, except here we're just going to look at three different examples of factoring. Okay, so this is similar to what you would have done in grade 10, just sort of up to the next level here. Let's take a look at the first one. It says, example 1, solving a quadratic equation by factoring. 0.125x squared minus 0.875x minus equals negative 1.5. Okay, so this at first looks like a pretty awful trinomial to try and factor. Okay, the first thing we're going to do is we're going to get it into standard form, which means we need to get everything onto one side. So I'm going to move the 1.5 to the other side. Okay, this is going to leave us with 0.125x squared minus 0.875x equals, plus 1.5 equals 0. Okay. Now, to factor this right now would be hard. Okay, but luckily, all of these can be divided by 0.125. So we're going to divide them all by 0.125, which is going to give us x squared, oops, I meant to write that down, x squared minus 7x plus 12 equals 0. Okay. Now, this is a much more manageable trinomial to factor. Now we're looking for two numbers that add to negative 7, multiply to 12. Those numbers are negative 4 and negative 3. So this is going to be x minus 4 times x minus 3 equals 0. And then if you were asked to factor, sometimes it asks you for, it might say the roots or the zeros. They all just sort of mean the same as the x-intercepts, okay? So we're just going to make these both equal to 0. X minus 4, oops, equals 0. X minus 3 equals 0. So our answers are 4 and 3. Okay. So once again, we took a question that looked really bad at the start. We got it into standard form. We were able to factor, divide all of them by 0.125. That got us to a manageable trinomial, which we were able to factor, solved for both of our x's, and got our answer. Okay. So we have two more. The next one is called a difference of squares. Okay, now some of you may have done a difference of squares before. If not, there's certain requirements that have to be met to factor by what's called a difference of squares. Step 1 is it must be subtraction, which it is. Okay, difference of squares means subtract. You have to be able to subtract. Okay. Step 2, the exponents, any exponents you have, they must be even. Okay, our exponent is even. That's good. both terms must be perfect squares. Well, right now, 75 and 192 are not perfect squares. If they're not perfect squares, look for something that you can factor out, okay? And both of these can be divided by 3. So we're going to factor out a 3 out of 75 and 192, which leaves us with 25 x squared minus 64. Okay. Now let's examine what's in the brackets once again. Our exponent's even, that's good. We have subtraction, which is good. And now both of these, 25 and 64, they're both perfect squares. Now we can do what's called a difference of squares factoring, okay? And here's what it looks like. So the 3 is just out there. He just hangs out. He doesn't do anything else for the rest of the question. We're going to make 2 sets of brackets. Okay? You're going to make one of the brackets, they're going to make 2 binomials. One of them is with a plus sign in the middle, one is with a minus. It doesn't matter whether you put the minus first or the minus second, as long as one of the brackets has a plus and one of them has a minus. Now we're just going to take the square root of both of these. The square root of 25x squared is 5x. So we're going to go 5x here and 5x here. The square root of 64 is 8. So we're going to have 8 here and 8 here. And now we've factored this binomial using a difference of squares. And if you were to multiply these 2 binomials together, you would end up back with 25x squared minus 64. After you do the difference of squares, we're just going to make both of these equal to 0. 5x plus 8 equals 0. 5x minus 8 equal to 0. And we're going to solve for x on both of them. This will be 5x equals negative 8. 5x equals 8. So we're going to end up with x equals negative 8 over 5. And over here, x equals positive 8 over 5. And that is our answer. Those would be our x-intercepts, or our roots of this equation, okay? So anytime you have 2 terms, it's possible it could be factored using a difference of squares. So just while you're writing it down, I'll just talk through the steps once more. You make sure it has to be subtraction. The exponent has to be even. Both terms must be perfect squares. If they're not perfect squares, perhaps something can be factored out, which will then make them perfect squares. And the square root of the first one goes as the first term in the binomials. Square root of the second term is the second term in the binomials. One's plus and one's minus. Okay? One more question. Example 3 says to solve a quadratic equation with only one root. In some cases, you can have a quadratic equation that only has one x-intercept, okay? Everything we've drawn so far has always had 2, right? Now we're going to look at what can happen, how you can only have, sometimes you only get one x-intercept or one root, okay? So I've got 4x squared plus 28x plus 49, okay? There's nothing common between 4 and 28 and 49 that I can factor out. So if you remember from Foundations 10, to draw a line, first 2 and last 2, you're going to factor using decomposition. So you're going to add to the middle term, which is 28, multiply to the last term, which is 196. I'm just trying to find the numbers again. Oh yes, it's no. Oh yeah. The two numbers that add to 28 and multiply to 196 are 14 and 14. Okay. So if you recall, I know factoring by decomposition usually isn't students' favorite thing to do. What you do is you rewrite this trinomial, but you've split the 28 up into the two new numbers. Then you group the first two and the last two. Out of the first two, you can factor a 2x, leaving us with 2x plus 7. And out of here, we can factor a 7, leaving us with 2x plus 7. 2x plus 7, those are the same, that goes down. What's remaining? 2x plus 7, 0. Now, you can notice, hopefully, that these two are the same, right? They're both the same. So when we solve it for 0, we get x equals negative 7 over 2, or negative 3.5. That's our answer. We only have one root, or one x-intercept. Now, what would that look like on a graph? It would look like this. It would be something, if this is negative 3.5 right here, this would be a parabola that would do something like this. It would come down, touch the graph at just that spot, go up and away. Okay? So that's what the graph excuse me, that's what the graph of a quadratic equation would look like with only one root. Okay? Well, 7.5 is just a sort of a brief review of some factoring strategies. The assignment is not long. It is just your workbook, page 195, numbers 1 to 6, and 11. And there's a number of factoring questions there to sort of rebuild your skills. All right? So let's work on that. Next day we will have a 7.6 lesson, and then we will have a 7.4 to 7.6 quiz. Thank you. Have a good day.